calculator available?
I do, yes.
Okay, perfect. Because we're going to use that for these calculations. Okay. So it says, this is question 2. It says the student is curious and asked a simple random sample of 250 students at school if they paid more than $100 per month for gas. 18 responded that they did. So it looks like the kind of the basic fork here in these problems is it a proportion or is it a sample mean?
Okay.
And I guess I can give you some hints here. Proportions, obviously there could be some percents. There also tend to be only 2 possibilities. They like yes or no, right or wrong, A or B kind of thing.
Mhm.
So what do you think here? Is this a proportion or is this a sample mean? And another also, sorry, good. I was gonna give you some more information.
Is it a proportion?
It is. Another thing with the sample mean is they have to tell you the mean and they have to tell you the standard deviation.
Okay.
Which they don't do in this one. So you know that it's not a sample mean, okay? And that's kind of what it asks here. Population mean or population proportion. You've answered correctly. It is a proportion. So for a proportion, if you go look at the formula for it, you need the proportion. Like you have to have the proportion to be able to do this. So in this problem, what is your proportion? Sorry, got too far away. What is the proportion here of students that responded that they did?
18.
Out of how many?
Out of 250.
Yes. So this is your proportion. That's your p-value. What is your sample size?
Is it also 250?
Yes. Yes. Very good. Okay. So this is enough to be able to do the confidence interval. Let's see what it actually asks for. So they want a 90% confidence interval. C equals 0.9. Okay. Do you have your calculator out?
Yes.
All right. So I'm going to grab mine. All right. Share screen. Okay, so where to go? It's either under stat or it's under distribution. This is a 1 proportion interval. A.
Okay.
So that was under stat, and then you go over to tests, and then A. Hit enter. So this is asking for X. X is the numerator. X is the 18. And there was an issue last time where I said X has to be a whole number. That's still the case. C is 0.9. And then before you calculate, just scan your numbers and see, see if that helps.
Okay.
Or what you get, but because I know there were some issues last time, like you didn't get the right numbers in there.
Yeah. It looks correct so far.
Okay, and then just go to calculate, and does your answer match mine?
Yes, it does.
Okay, so now we can ask some other questions, and it's good to write these numbers down. So like get your window down 0.04511, 0.09889. Now the width of the confidence interval is the larger number minus the smaller number. And sometimes they ask for that. So that's the width of the confidence interval. Okay. Now the margin of error is you take that number and you divide it by 2.
You take the width and divide it by 2?
Yes. Yes. So I'll show you that here graphically on the other screen. So the idea is that you found that the left side of the interval is 0.04511, 0.09899. The width is the 0.05378. That's when you subtract them.
Mm-hmm.
The margin of error, though, is half the width. And that was the 0.02689.
Okay.
Any questions on that?
No.
Okay, so here's what I want you to do on your own is to change the confidence interval to 99, and I want the width, okay, of the new confidence interval. So your only thing you're gonna change is the C value, and then you're gonna take that right value and subtract the left value.
Take the, can you repeat that? Sorry.
Yeah, so once you calculate the confidence interval, you're going to have those two numbers on the screen. You're going to have the lower bound and then the upper bound, and you just take the upper bound and subtract the lower bound.
Okay.
And I'm doing it too. I just want to see work this, just this calculation on your own here. And you can even tell me your new interval if you want.
Um, 0.04211.
Are you giving me the full width?
Yes.
Okay, so did you get 0.02989 to 0.11411?
Yes.
Okay, and then when you subtract them, I wasn't that far. I thought you were gonna give me that other value, but that's great that you already have it. Yeah, the width is 0.08455. Is that what you said? I'm sorry, I didn't. But
I got,
these are, oh, go ahead.
I got 0.08422.
All right, so we're just slightly off. I mean, maybe I put the wrong number in. That's why. Yes. Okay. So the width of the 90% confidence interval is 0.05378. The width of the 99% is 0.08455 or 811. Which is larger, the 90 or the 99%?
The 90%.
This one here. I'm just asking which number is bigger. The
The 99 is
yes.
bigger.
Yes. So like that's one of the biggest conclusions they're asking you to draw from this is that as C increases, the width also increases.
Okay.
All right. So let's do a new problem here. We'll do a Super Bowl themed problem. What do you think the first ad will be on the Super Bowl next Sunday? First commercial.
Oh, that's a great question.
Yeah.
I don't know, probably like I don't know, maybe Pepsi or something like that.
Yeah, let's go. I was thinking Pepsi because they have historically done that. So let's say you ask 10 people, and you find out that 6 like Pepsi. Okay.
Okay.
And I want a 95% confidence interval on the proportion of people that like Pepsi. Okay. So remember, your calculator needs X, N, and C. Can you tell me those values from this problem we've just created?
C is 0.95.
Good.
Um,
N stands for the number of people that we're sampling.
oh, so N is 10 and X is 6.
Good. Okay, I want you to go calculate the confidence interval for us for that one.
Okay. Um, 0.29636 to 0.90364.
Okay, and can you calculate the width for me as well here of the confidence interval?
Yeah. Um, 0.6. Oh wait, that's I have to divide it. Let's see.
No, that's the width. And then the margin of error, you divide
Oh
that
yeah.
by 2. So let's do that as well. Give me the margin of error as well.
The margin of error is 0.30364.
Good. Okay. So now 10 people is a very small sample. Would you agree with that?
Yeah.
Okay. Now let's do the following. Let's say we have a much more, our budget's gotten bigger, and we can actually ask 600 people. We find that 600 people out of 1,000 like Pepsi.
Okay.
And we want to do the same thing. We want to do a C equals 0.95 confidence interval. So again, before you go to the calculator, or when you go to the calculator and it's it's got these things that you're supposed to enter, that you should write those down on your paper and then fill those in and say, okay, which is what are the values here. So before you go and enter yours, please let me know what you're going to enter for that.
X is 600.
Okay.
N is 1000 and C is 0.95.
Okay, so very similar to the last one, but different numbers for X and N. Go ahead and calculate that whenever you're ready. Let me know what you come up with.
The interval is 0.56964 to 0.63036.
Okay, so then next I'd like the width of the confidence interval.
The width is 0.06072.
Okay, what would the margin of error be?
The margin of error is 0.03036.
Good. Okay, so here is what we did in this problem. We first had a sample size of 10, and we had a width of 0.6. Then we increased the sample size to 1,000. What happened to the width? Did it go up or down? It was 0.6. Now it's 0.06.
Yeah, it went down.
Yeah, so this is the other sort of big thing here. As n increases, the width decreases. Right, so those are our like two summary statements thus far in the lesson. This one, that as n increases, the width decreases, and then previously, as the confidence interval increases, the width increases.
Okay.
And those have to be like super clear as you head into, test at some point.
Yeah.
Okay. All right, are you ready to I've got some other problems here. Because yours kind of runs out of problems. Nope, I guess there's some other ones here. Portion. Okay, let me grab some new problems. That's okay.
Okay.
All right, so here's a new problem, something you've never seen before, but so I want you to decide if this is a population proportion or a population mean.
It's the population mean.
Yes. Okay, so now I'm gonna go to the calculator. I'm gonna go to stat again. I'll pull it up in a minute, but I want to make sure I know what it asks for. So this is a Z interval, I think. Yes, this is so in your calculator, this is gonna be a Z interval. And it needs to know once you give it the stats, let me hit enter on that. It wants to know sigma, X bar, N, and the C value. So if you're not sure what I'm talking about, it's stat tests 7. And then you have to choose what do you have to choose? You have to choose the stats instead of the data. Are you seeing something that looks like this? Is sigma, X bar, N, and C?
Yes, I do.
Okay, fantastic. So looking at the problem again here, what of these do we have? What do we not have?
You have the mean and standard deviation, so you need the confidence level and the sample.
Okay, so let's say we're going to sample 24 and we want a 99% confidence interval. All right, so go ahead and calculate this for us, please. Let me know what you get when you're done.
I got 51.845 to 58.155.
Good. Good. So I'm going to type this question. Would it be unusual for a 10-year-old to be 5 feet tall? Okay, so you cannot bring in your personal feelings, emotions about this. It's literally asking you to decide, is that number in the interval or not?
Which number is in the interval?
5 feet, 5 feet. So you may have to do that quick, calculation to from inches to feet or feet to inches.
Oh, I think that the interval is a little bit, it's a little lower.
Right. So 60 inches, it's kind of like, and sometimes they even show this on a number line. Like here, let's just say 60 is here. Your interval is here. And 60 is above it. Similarly, if I asked for 4 feet, would that also be unusual?
Yeah.
Yeah, because 48's kind of here. And you're making this claim, but again, about 10-year-olds, not about people in general, just this group.
Yeah.
All right. Let's find another one here. This one was more complicated because it's awkward. All right, so I want you to read this over and tell me if it's a proportion or a population mean problem.
Population mean.
Yes. Okay, so there's a lot going on here. What is the mean and standard deviation?
The standard deviation is 33%.
This one's a little awkward because it's in percents. I was working this problem with a college student, and it didn't matter when we did it whether it was a percent or a decimal, but it's a little weird. I'll say that. What is the mean?
Um, is it 14.7%?
Yes. All right, and let's just say we'll go 12 samples, and let's do an 80% confidence interval this time. Okay, so go ahead and calculate that and let me know not just the interval, give me the width as well and the margin of error. So 3 things: the confidence interval, the width, and the margin of error, please.
Okay. The interval is 2.4916 to 26.908.
Okay, good.
The width is 24.4164.
Good. And the margin of error?
12.2082.
Very good. Okay, now in the context of the problem here, would a return of 0% be unusual? So you can type that here. Would a return of 0% be unusual?
Yes.
Yes. Now, the way you should interpret these questions, regardless of the situation, is this number in the interval? If it is, then that's okay. That's reasonable. But if it's not, then yeah, it would be unusual to get a return like that.
Mhm.
Okay,
Okay.
now this is great. Now, I don't want you to do calculation. I want you to look in your notes or have me scroll back. But let's say I made an error and I said, oh, you know what? N isn't 12. N is actually 120. There's my coffee cup. I didn't see the 0. How does this affect the width of the interval when the sample size increases?
Um, so as the sample size increases, the width decreases.
Okay, so I'd like you to go and recalculate your width and show me that that is true for this one for 120 instead of 12.
The width for 120 is 7.722.
So as you said, it did get smaller. Good, good. That's really important here. So there's kind of this like I don't want to say this not interpret question, but it's like what does this tell you about the importance of sample size? And you just said it. You said the width got smaller, but what can you give me any more information than that?
Um,
Like a real life example of why that would be important.
about like when the sample gets bigger, the width decreases.
So here, so yeah, but let me give you more. Let me try to lead you in the right direction. When the width is smaller, you're more certain about whatever it is that you're measuring. So like use the Pepsi example. If we have 6 out of 10 people versus 600 out of 1,000, we feel more confident about what we're doing because we have a greater sample. We've asked more people.
Mhm.
So we're more confident about where that width would be.
Yeah.
But like, what does that mean? Like, and think of in terms of like, have you done any surveys in this class or any sort of sampling in this class?
Um, a little bit, but not enough.
Yeah, so surveys are it's really hard to collect data in real life, meaningful data. But what this is trying to show you is that you should basically sample as many people as you can. Trying to think of a meaningful example, but like you're going into, you've got a path here into the Navy, and if you
Mhm.
like if you talk to 3 people or you talk to 30 people, which is better about the experience that you would expect?
Um, Probably 30 people.
Yes, it would be better. But what is the challenge? Like what's the practicality of that? Is that reasonable to go from 3 to 30?
Um, Not really. That's kind of a big jump.
Yeah. And it's time consuming. You got to ask the right 30, that there's a lot there. But the idea is that if you could ask more people, you would have more chance here of getting the result that you want. All right, so let's Let's look at one more problem here. You like dogs, is that right?
Yeah.
Okay, so here's a dog example. I don't know if this is true about how big a Saint Bernard is, but um, this problem you should be able to do from start to finish with what we just talked about. So give that a try. If you have questions along the way, please ask. So just the confidence interval, if you got that.
Okay. The confidence interval is 185.27 to 200.73.
Good. So again, kind of the same question here is if I said, would a 200-pound Saint Bernard be unusual?
No.
No, it would not. Okay. Here's another one, a proportion problem for us to look at. Now, I'm telling you that because this one's got a problem that we kind of looked at last time, but we'll see if we can more fully understand it. So this is in a random sample of 250 high school students. It was found that 85% of them later graduated. Okay, so find the 98% confidence interval for the true proportion of that. So it's telling you proportion, which means that you need X, N, and C. So C is 0.98, N is 250, but what is X? What is X in this problem? And it's related to these two numbers right here.
Oh, so it's 85 over 250.
It's 0.85 times 250.
Oh, okay.
It's N times P. So what do you get when you multiply those together?
Um, 212.5.
Yes, and here's the problem with your calculator. It will reject this. If X is not a whole number, it will reject it.
Okay.
And you can't increase N, that's not allowed. So my question to you, or thought for you, this is to ask the teacher, is what should you do in this situation? Should you go back, I'm grabbing the snip of it. Should you go back and use the formula without the calculator? Because you can do this, but you can't use the calculator for a problem like this.
Okay.
And that's something like, I want you to know is that you don't have this unsettled feeling when you go in there on the test.
Okay.
So would you like us to do this using the confidence interval formula now?
Yes, please.
Okay. So sometimes this isn't very helpful. We need P. What is P in this problem? P is your probability, the percentage, you can think of it as.
85.
So 0.85. 0.85 because it's a decimal. Is that okay? Is that clear?
Yeah.
N is still 250. C is still 0.98. Okay. Now when we use the formula, we have to come up with the Z value. And this is going back to the calculator now. So let's see if we can find that. I believe that was under distribution, second distribution. And that's above vars. Let me see if I can find it before okay. This is the one. So can you do the inverse norm option, second distribution, inverse norm? Yours is going to have it written out.
Where it's area, mean, and standard deviation.
So so yours has area, mean. Does it have like a tail issue?
Yes, left, center, right.
Okay, so left, center, and right. Okay, so for confident intervals, you want to choose center. And that value is the confidence interval of 0.98.
Okay.
I'm sorry, the area is 0.98. Let me back up there. The area is 0.98. The mean is 0 and the standard deviation is 1. So the 0 and 1 is used for what's called standard normal. So go ahead and calculate that and let me know what you come up with.
I got -2.326347877.
Yeah. Good. So everything we just did was to find the Z value. Because if you look at this formula, you need the P hat, which you have, the Z value, which you now have, the N, which you now have.
Okay.
All right. So now what I would do before I went to the calculator to write this in is I would just substitute those values here. So it's 0.85 plus or minus 2.33 square root 0.85 1 minus 0.85 over 250.
Okay.
So give that a try. Do the plus first and then the minus, I guess. You got to do them both, but
Okay.
go ahead and see if you can calculate those. And if you have issues, let me know. I'll try to help as best I can.
For the plus, I got 0.7973.
Yeah. Yep. Good. For the other.
And then for the second one, I got 0.9026.
Good. Really good. Okay, so let's do a few more of these Z calculations for this. So I'll make up just another quick problem here.
Okay.
So let's say you know that 12% of students, I don't know, own a, well, it doesn't really matter. I don't know. I'm trying to think of something meaningful, but 12% of students do something. You can fill it in later. You sample 321 of them.
Okay.
Okay. And you want a confidence interval of 0.85. Okay. So the issue with this problem, because you'd really like to go to the proportion, right? You'd like to say, okay, 0.85 for C, N is 321, but X is N times P. And I'm pretty sure 321 times 12% does not give you a whole number.
Okay.
In fact, it gives you 38.52. So your calculator will reject that, which means you have to go back and use this formula again.
Okay.
Okay. And so you have a lot. You have P. P is the 12%. Okay. You know that N is 321, but what you don't have is Z. Okay. And you've got to go to your calculator and find Z for me now. Okay. So the area is 0.85. The mean
Okay.
is 0, standard deviation is 1, and it's a center because the confidence interval is centered in this case. So go ahead and give that a try, please. Let me know what you come up with.
I got negative 1.439.
That's correct. So it's typical to go to about 2 decimal places. So this time I want you to fill in the formula yourself and try working it out, getting your confidence interval there for this.
Okay. So for the first one, I got the positive one, I got 0.0765.
Ooh, we got something slightly different. So let me just check here. Did you, so it's 0.12 plus or minus, and then minus 1.44 square root 0.12, 0.88, or 1 minus 0.12. So sometimes it's better to subtract it than to leave it as that over 321. Is this what you have?
I had 1 minus negative 1.44.
You're saying this one right here, minus 1.44?
Yeah.
Okay. So that's the same, 0.12 plus or minus 1.44 square root of. I'm trying to see where the difference is, because
I left like in the so under the square root in the parentheses where it says 1 minus p hat, I had 1 minus negative 1.44.
okay, that will do it. So you end up getting, if you have time, you can obviously redo the calculation, but it's 0.0939 to 0.1461.
Mm-hmm.
Doing it this way. So probably, probably you want to ask about the whole, like what we've been doing the last few problems, when you get that, where the calculator rejects the X because it's not a whole number. That's something to maybe ask your instructor about.